Hey everybody, welcome back. Morgan here. We're going to be finishing up a couple of the balancing redox equations in base questions today, and then it's going to be time for us to start turning some work in again. So I want to do one or two of these from the back and then leave the rest of them for you guys, and that's what we can be grading you on. So the first thing that I think really grabs my attention is number 6. And the reason for that is you have a reactant that's the same in both reactions, both half reactions. Cl2 gives you Cl minus, and Cl2 gives you ClO minus. Okay? Now, that means I'm going to have to do step 2. I have to put a 2 in front of that, and I have to put a 2 in front of that. That's the balance everything except the hydrogen and the oxygen. Now, no oxygens, no hydrogens there. Not going to worry about that. I do have an oxygen here, so I'm going to add a water. Because that has 2 hydrogens, I'll add 2 waters and 2 hydroxides. Then, in terms of charge, I have to add 2 electrons there. Now here, I have a 2 minus, and I have a 2 minus, which tells me that I have done something wrong. Okay? I counted my oxygens wrong. So, I had put a water here to balance 1 oxygen when I should have put 2 waters to balance the oxygens, which means I have 4 hydrogens total, so that's really a 4. And then that means this has to be 4 hydroxides. Okay? So, 4 minus and 2 minus, I'm going to add 2 electrons, and ooh, that's good. Okay? It doesn't look clear. Let me just rewrite that for you guys. 2e minus plus. Okay. So that means these electrons can cancel, and that's the only thing that's going to cancel. So what do I have? I have 4 OH minus, 2 waters, 2 Cl2 to give me 2 Cl minus plus 2 ClO minus and 4 waters. Now, I'm hoping you are tuned in and actually seeing 4, 2, 2, 2, 2, 4. I can take and divide that by 2. I can reduce that. 2 OH minus plus an H2O plus a Cl2 gives me Cl minus plus ClO minus and the 2 waters. And those 2 waters can actually take that just down to 1 water. And then what I end up with for my final equation is right there. Okay, so that's number 6. Now number 7 tends to bother a lot of people also. MnO4 minus gives me MnS, and S2 minus gives me S. Now, this is actually a redox reaction right here. But the sulfur does not change its oxidation number up here. So I'm just going to leave it in there as an ion that's taking part in the reaction, but is not changing. It's not being oxidized or reduced itself. So that's how you get those. Now, 1 manganese, 1 manganese, 1 sulfur, 1 sulfur. That's good. 4 oxygens. I add 4 waters. 2 times 4 is 8 hydrogens. So 8 water, 8 hydroxide. Down there, the 2 electrons. Got to count carefully up here. 8 minus, 2 minus, and 1 minus is a 3 minus. That's a difference of 5. 5 electrons. So I'm going to have to do some real multiplying here. Multiply this by 2 and multiply that by 5. I like to change colors when I do that, kind of make things easier to read. No reason for doing it beyond that. 10 electrons, 16 waters, 2s, 2 minus, the sulfides, 2 MnO4 minus, gives me 2 MnS, 2 times 8 waters, and 2 times 16 hydroxides. Down here I have 5 S2 minus to give me 5s and 10 electrons. Okay. 10 electrons cancels 10 electrons, and 8 water takes 16 down to 8. So now, going into another color here, 8 water plus 2 sulfides plus 2 permanganate. Plus S2 minus yields. Let's see, that's going to be 5 of those. 2 MnS plus, those are gone. So here we have 16 OH minus and the 5 sulfurs. Okay, so let's check my charge here and see if I did this right. Okay, 2 times 2 is 4 minus, plus this is 6 minus. Okay, 6 minus plus 2 times 5 is 10. 16 minus. I got a lot of minus there. Over here I got, 16 hydroxides. 16 minus. So it works out. That's balanced. Okay, so those were 2 of the more challenging ones on the back. In number 8, you do a similar thing that you would do in number 6. You can have Br2 be the reactant in both of them. Okay? All right, so finish off the rest of these, and we'll be collecting them at the beginning of next week. Okay, Morgan, signing off.